that we do have different types of decision tree based on the attribute selection measurements, which one we have selected. Depending on that, we will have different types of decision tree. And you have seen that there are three of them mainly, that is information gain, gain ratio, and Gini index. Let's try to compare them. See, when this is information gain, then it is biased towards multi-valued attributes. And if it is gain ratio, then it tends to prefer unbalanced splits in which one partition is much smaller than the others. And if it is Gini index, it is based, means biased towards the multi-valued attributes and has difficulty when number of classes is large, and tends to favor tests that result in equal size partitions and purity in both partitions. So now it's on you that which one you will select based on the data set you have considered. So কোনোবা এটা তোমাৰ big data set কাৰণে ভাল হ'ব পাৰে, কোনোবা এটা নহয়. So you need to find it out. Like this Gini index, it is clearly mentioned that it has difficulty when the number of classes is large. Some other attribute selection measures are there. I don't think that they are so important for you. Now, one problem is there that you have to know, and that is known as overfitting problem. Okay, so what is overfitting exactly? Overfitting means an induced tree may overfit the training data. You know that the process is from training to the testing phase. We keep growing that tree, right? But whenever the tree grows in such a way that now for the new data nodes, you will hardly find space there. Means there are too many branches. Some may reflect what anomalies due to noise or outliers. So overfitting is a problem in the case of decision tree. It happens when we will have too many branches, which the tree keep growing and growing, and exactly that is because of some noise and outliers. Okay, so because of the overfitting, poor accuracy for unseen samples may be happen. Means you cannot expect a good accuracy out of a decision tree which is suffering from overfitting problems. So ओवरफिट होइसे इसका मतलब क्या है कि ट्री में जितना होना चाहिए उससे ज्यादा आपका ब्रांचेस ग्रो हो रहा है. ठीक है, तो ऑब्वियसली आपको क्या करना पड़ेगा? You need to cut off some branches. Obviously in this case this means that you need to cut off some unneeded data points, or need to cut those outliers out of that tree. And for that you have two approaches. One is pre-pruning and other is post-pruning. ठीक है सर, प्रूनिंग माने होसे कि काटी पेलो. मीन्स प्रूनिंग का मतलब क्या है? जो ओवरफिट हो रहा है, जो ब्रांचेस ज्यादा बढ़ रहा है, हम उसको अवॉइड करते हैं, उसको कट आउट कर देते हैं. ठीक है, अब ये प्रूनिंग भी दो टाइप का है. कि क्या से? One is free pruning. From the name itself is very clear that it is free. Okay, means we are going to avoid that overfitting problem in advance, right? And post pruning, post means it's already done. Now we are trying to prune it. So let's see about this pre-pruning. Pre-pruning means halt tree construction early. Do not split a node if this would result in the goodness measure falling below a threshold. मतलब क्या है कि आप जानते हो कि हम अभी तक तो आप समझ गए हो कि डिसीजन ट्री में हम नोड का चिल्ड्रन जनरेट करते जाते हैं, राइट? अब इन नोड में से क्या कौन सा नोड सिलेक्ट करके, to which node will select, it is based on those different measures Okay, this beginning of the lecture, I told you there are different of them, and in the yesterday, last class also, the Gini index, that means entropy. Okay, there are different measures. Now, based on those measures, we select that node like this one. আমি এইটো select কৰিম। এইটো কেনেকৈ select কৰিম? How will select it? इन दोनों का जो वैल्यू मिलेगा, सपोज कोई भी गिनी इंडेक्स कंसीडर कर लो या तो इंफॉर्मेशन गेन कंसीडर कर लो, तो उसके बेस में हम एक नोड सिलेक्ट करके उसको स्प्लिट करते हैं। स्प्लिट मीन्स व्हाट? वी आर जनरेटिंग दैट चिल्ड्रंस ऑफ दोस दैट पर्टिकुलर नोड। नाउ ये जो हमने नोड सिलेक्ट किया, दिस इज बेस्ड ऑन सम वैल्यू, दैट सपोज गिनी इंडेक्स वैल्यू इज some 0 something, and based on that we are going to split that node. आप क्या करेंगे कि हम एक थ्रेशोल्ड मान लेंगे, वी विल कंसीडर वन थ्रेशोल्ड वैल्यू। ठीक है, जैसे कि 0.5 होने से ही हमने इस नोड को स्प्लिट किया था। 0.5 का वैल्यू क्या था एक्चुअली? व्हाट इज दैट 0.5? दैट वैल्यू इज द actually those either gain index or those entropy information gain. Okay, so now we'll consider say 0.7 a threshold value. We will split that node only when it reaches the threshold value. Otherwise, we'll halt the tree construction. मतलब है कि थ्रेशोल्ड वैल्यू पास किया तभी हम क्या करेंगे, उस पार्टिकुलर नोड को स्प्लिट करेंगे। अदरवाइज वी आर नॉट गोइंग टू स्प्लिट इट, राइट? सो এটো কেতিয়া কৰিছো? When we are doing that exactly? Tree to construction হোৱাৰ আগতেই কৰিছো, right? ট্ৰিটো কেতিয়া কনষ্ট্ৰাকচন হৈছে? যেতিয়া তুমি নোডটোৰ পৰা এনেকে বহাই গৈ আছা। So that's why this is known as pre-pruning. আমি prune কৰিছো, we are pruning it exactly, but before that construction of the rest part of the tree. Okay, so this is totally based on that threshold value. If you choose that threshold value wisely, then obviously that is this one is a very good or nice approach. But the problem is that how to choose the appropriate threshold. Is a threshold value to select korisa? That is a very difficult thing, very tough thing. So that is the disadvantage associated with this pre-pruning process. Now coming to the post-pruning. So post-pruning remove branches from a fully grown tree. Get a sequence of progressively pruned trees. Use a set of data different from the training data to decide which is the best pruned tree. Okay. Remove branches from a fully grown tree. इसका मतलब अभी opposite हो रहा है। अभी opposite मतलब आपने पूरा tree को grow कर लिया था। पहले ऐसा हुआ था कि grow हुआ ही मतलब grow करने से पहले threshold compare किया। अभी ऐसा नहीं है। The tree is fully grown now. Now what you will do, you will try to remove the branches. Okay, based on the thing that from the training data, you have to decide that yeah, this is the base prune tree. We may cut down this part of the tree, and it is not going to affect on the classification result. So that is post pruning. We are removing the branches from a fully grown tree. Now, I hope that you got the difference between this pre-pruning and post-pruning. So, simple question to you: what, according to you, will be the will be the best one among these two for our to deal with overfitting problem? You'll think about me you'll think about this and you'll let me know. Okay, means pre-pruning or post-pruning. So you'll just go through some example that that will means clear this fact that which one will be the favorable one with respect to what situation. Okay, it's a homework for you. You will go through it. Now, so what decision tree we have discuss is the basic one. Okay, so what happened? There are different ways by which you can improvise the performance of this decision tree. Like few points that you may know that if you allow the continuous valued attributes, if you handle the missing attribute values, okay, if you go for a constructive method for those attribute generation, then if you allow these things, our basic decision tree induction will be an improvised version. मतलब क्या है, आप अगर continuous value को allow करोगे, तो continuous value exactly what does it mean? Dynamically define new discrete valued attributes that partition the continuous attribute value into a discrete set of interval. So now what happened? We are allowing continuous valued attributes and it is purely dynamic one, right? And also we try to handle the missing attribute values. It's a very common problem in machine learning. ঠিক আছে, বহুত important হয় তোমালোকে those who have interest in this area, you will find this obviously in the pre-processing phase, that what is missing attribute and how to handle problems related to missing attributes. Okay, so missing attribute to deal करातु एता pre-processing का task है. हम क्या करते हैं, pre-processing phase में ही missing attribute को deal करते हैं. इसमें क्या करते हैं, मिसिंग एट्रीब्यूट का मतलब तो समझ में आ रहा होगा. ये ढेर सारे हमारे पास एट्रीब्यूट हैं. ये सपोज ए एट्रीब्यूट है, ये बी एट्रीब्यूट. ए एट्रीब्यूट का कुछ कुछ वैल्यू मिसिंग है, तो हम क्या करेंगे, विल असाइन द मोस्ट कॉमन वैल्यू ऑफ द एट्रीब्यूट एंड असाइन प्रोबेबिलिटी टू ईच ऑफ दिस पॉसिबल वैल्यूज. जो मोस्ट कॉमन वैल्यू है विल पुट फॉर दोस मिसिंग एट्रीब्यूट, एटलीस्ट विल नॉट लिव इट ब्लैंक. Okay, then whenever it is needed, we go for generating some attribute with some constructive way, like create new attributes based on existing ones that are sparsely represented. Now, look at this term, sparsely represented. तो sparsely माने गुंजी भाई साहब की हो, sparsely का मतलब समझ में आ रहा है क्या है? वो एट्रीब्यूट सारे वैल्यूज को रिप्रेजेंट नहीं कर पा रहे अच्छे से. ओके, द फार फ्रॉम ईच अदर. ये जो डेटा पॉइंट्स में ड्रॉ कर रहा हूँ ना, दिखाई दे रहा है आप लोगों को. They're far from each other, they're sparse in that space, right? So this means what? If we construct more attribute now, if we construct more attribute, say two attributes, then they will be now more clearly represented. Okay. So in the cases when the values are sparsely represented, then it is recommended that we go for constructing some new attribute based on that existing ones. And hetur por amar ki লাভ, what we will get in return exactly? This will reduce the fragmentation. You all know that what does it mean by the fragmentation? Then repetition, replication. So some problems we may face if we consider single attribute to denote or represent those sparsely situated data values. And they are like fragmentation, repetition, replication. So why not to create more attributes and represent them uniquely? So these are the basic measures by which you can improvise our basic decision tree induction. Means question ahibo pare, question aisa bhi puch sakte ki what are the possible measures you may take, you may consider to improvise the performance of the decision tree algorithm. Then you need to mention this, like allow for continuous valued attributes, to handle missing attribute values, to generate some new attributes from the existing one. This will be the answer for that. Okay. Now large database. So large database बोली जब मैं कहूँ, जब मैं large database की बात करता हूँ, तो exactly large database, by the term large database, what you mean? কি বুজি পোৱা তোমালোকে large database বুলি ক'লে? Can you give me, can you cite an example for that? Okay, so do one thing. Today you try to search that what this does. मतलब তোমালোকে तो শুনিছা big data বুলি এটা term এটা আছে, सभी ने सुना होगा, मुझे sorry, big data লগত v cube বুলি এটা শব্দ জড়িত আছে. With respect to big data, you will find a term v cube. Anybody can you define that? What is v cube? So please go through it.
Volume.
Person?
Volume. Variety or hard to power.
At least you have tried. Okay, very good. So with this time, we try to define this big data or large database. That's why I am calling them. Okay. So other students also, at least a big data definition to logot ever thakiba. Okay. You may find various resources in that. Even I also have one research paper in that area. You may search it. Big data in medical imaging field. Okay. So in that paper, we are dealing with those different kinds of resources which are contributing towards generating big data. Okay. So you may search that paper by my name and you can find it. Means at least read the introduction portion. Even from the abstract part also, you'll get some idea about that big data. Okay. So এই যে big data হয়, large database হয়, তাত classification কৰাটো केनेকুৱা ধৰণৰ चैलेंजिंग হয়. Okay. जो big data है आपके पास, large database है. अभी जो हमने बात की थी, this the algorithm, this NP algorithms we are applying, those are related to our traditional databases, dataset. Okay. Which is of course not big, right? So now thing is that if we consider a large database, if we consider big data, can we apply the decision tree algorithm on that? Or what are the problems that we are going to face, or what are the challenges we have to go through when we are dealing with just type of data? Okay, so we'll discuss about that.